Alrighty, well, welcome to day 3 of our Triangle Congruence unit. Today we're focusing on SSS, and we'll talk about what that actually stands for. Again, we're focusing on our proofs for triangles. That's where we're trying to prove something very specific about some kind of math, in this case. And we're practicing the skill of reasoning, we're practicing using logic, we're practicing proving our point. Alright? So here's the basics for today. We're focusing on SSS, we've got our standards, and again, these are all at the top of your notes page. Okay. Alright, so SSS stands for side, side, side. So you can go ahead and fill it in on yours. Okay, so we are focusing on the fact that if 3 sides of one triangle are congruent, and you can either write out the word congruent or use that symbol. If they're congruent to 3 sides of a second triangle, then the 2 triangles are completely congruent. Okay? So as you can see in the picture, every side is labeled as congruent, okay? And I would write all of them out just like we've been practicing. So AC is congruent to XZ, and then BC is congruent to YZ. Notice how I got all the symbols on there correctly still. And then BA is congruent to YX. Okay? And you can tell because of all the symbols there. There's 1 there, there's 1 there, there's 2 here, there's 2 here, so they all match up just like we've been doing. Okay? So today we're looking at if I can find 3 sides that are the same in both, the whole thing is the same. Okay? So if all the sides are the same, automatically all the angles have to be the same. Right? That's what this theorem is proving. Okay? So example number 1. Again, check your givens. Make sure they put all the information in there for you. Sometimes they do, sometimes they don't. This one tells us that KL is congruent to NL. Well, KL's right here, NL's right here. Looks like they've already marked it for us, so that was nice. They also tell us that KM is congruent to MN, right there. You can tell because they've got the double lines right there. So we have 2 sides given. Okay? And because we know that SSS, or side, 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 is one of our shortcuts that we can use, by the way, that's what this is. SSS is a shortcut. So before we were saying we had to find every angle, every side, everything had to be proven congruent. SSS is a shortcut that's already been proven for you. Okay, they already found out that if you prove all the sides, all the angles have to be the same. So we don't have to look at the angles this time. All we're doing is looking at sides. Alright, so 2 of them are already done. That means I need to find 1 more. Okay, this one's hopefully an easy one. Okay, if you look, the only side remaining is this guy right here. And it happens to be the same in both. So I need to put what is congruent. So LM is congruent to LM. And hopefully in your head, you're already thinking of the reason. Remember, you can't just say that it's congruent. You have to say why. And in this case, it's that reflexive property that we've been using quite frequently with these practice problems. And again, I'll just abbreviate as PROP. Right? And now I have to actually say that the triangles are congruent. Now this time I'm going to say why. Right? Because I haven't proven every angle and every side. All I've done is prove the 3 sides. I'm going to say that they're congruent by SSS. Okay? Which means that I've said that every side is the same, therefore the whole thing is the same. Okay? So I get to stop right there. Don't have to worry about any of the angles anymore. So it's kind of nice for you guys. Now you get to start learning all those nice shortcuts. So you don't have to do the entire shape every single time. Alright, so a couple of practice problems just to get the gist of the side, side, side. Alright, and see if they're actually congruent or not. Number 1, you need to pay attention to the sides themselves. Are they marked as congruent? Number 2, you have to actually pay attention to all these congruent statements. Remember I told you that the order matters. So if their letters are out of order, the statement is not true, even if the picture looks like it's congruent. Alright, so let's check my statement. This one says D goes with H. Alright, and that's true for this one. It also tells me that F goes with J. Could use a different color for that. Try that again. F goes with J. And I can see here that those are both the same part. They're next to the double and the triple lines. And then G is supposed to go with K, so that looks good. Every side is marked as congruent to the other sides. So I would say that we are good for that one. This is a yes. And it tells me to explain my reasoning. So I'm going to say that it's by SSS, side-side congruence. Side-side congruence, my bad. All right, let's take a look at the second one. First of all, let's look at our picture because they actually give us numbers this time. I've got 9 in the middle. That's the side that overlaps, so those are automatically equal to each other. I've got 2 sides that are 7. So I have side so far. But if I look at my last 2 sides, I have one that's 3, one that's 4. Obviously, those numbers are not the same. AB is not congruent. Congruent to CD, so that would be a no. Okay, and the reason is because one of the sides is not the same. All right, looking at the last one, check our picture. Looks like every side is matched up. I see 1, 1 there, 2, 2 there, and then 3 on the other. Check our letters up at the top. Do they match where they're supposed to? Q and R look like they're okay. And then we've got P and S. Those look like they're in the correct spot. And then T obviously has to match with itself. So this one is yes. Again, it's by SSS this time. All the sides are the same. Side congruence. It's a pretty great congruence statement. Okay? If you need to pause or rewind to listen to that stuff again, feel free to. Reminder, because we're going to keep looking at this. What does it mean to bisect a segment? Okay, so think about that for a minute. See if you can remember. Hopefully you can. All right. Bisect means to cut into 2 equal halves. If you did not remember that while I was giving you enough time to think of it, you'd better write that down because you need to know it. It's extremely important. You're going to see it pretty much every day for the next week. So you might as well write it down. Midpoint we haven't talked about in a while, but some of you probably can figure out what that means just by looking at that little prefix there. Mid means middle, therefore midpoint is the middle point. If it's in the middle, that means it's bisecting the segment, which means it cuts it in half. So again, if I have A to C, and somebody tells me that B is the midpoint, what does that tell me about the rest of my segment? Well, it tells me that it's split in half. B is the middle. That means this has to be equal to this. So I can mark those by definition of midpoint. It's automatically true. Don't have to do any extra math. I just have to say by definition of midpoint. Those 2 things are true. All right, so I put that off to the side. Put it in your notes somewhere. If you did not know that, I'd really make a note of that. Make it obvious. Okay, and then the last example we're going to cover today. This one's got a little bit more that we're working with. This one says QRS, so that's the entire triangle. Make sure you pay attention to the letters. QRS is isosceles. Some of you keep forgetting what that word means. Think in your head back to that unit we did with equilateral and isosceles triangles. An isosceles is a triangle with 2 equal sides and angles. 2 equal sides, 2 equal angles. Now, since we're focusing on side today, it's not exceptionally important that the angles are congruent, but we're going to mark them anyway, because we might need it for the future. And it tells us that QR is congruent to SR, so those must be the 2 congruent parts of my isosceles triangle. Think back to when we did isosceles. The 2 angles that must be congruent are the ones diagonal from that. So Q, and this line's kind of wonky because the smartboard is being crazy, but it's still opposite of S. And again, we're not really going to use the angles, but you should still be in the practice of using that. It's still important. You're still going to use it later. So let me rewrite that a little bit nicer. Those two are the same, and those two are the same. The sides are important. We do need that. All right, and then it also tells us RT bisects. Remember, bisect means to cut in half. 2 equal halves at point T. So T is cutting this line in half. Okay, well, it doesn't tell us what that means. You gotta use your brains and know what that means. This means cut in half. All right, well, we are smart. We are intelligent people. We have learned that bisect means it cuts into 2 equal halves. So if it's T in the middle, that means that QT is congruent to ST. And that is, again, just by the definition of bisect. Bisect means cut in half, so the definition itself proves it. The definition of bisect. And yes, I don't care if you think it's stupid that you have to write it. You do have to write it. Like we talked about, you can't just say why something is. You have to give a real reason. This is my real reason. Definition of bisect. And I'm going to mark my picture. Notice I'm using the double lines because they're not the same as this. Okay? They're their own little separate thing. I'm looking to prove that those are the same. Okay, well, I've got 2 sides so far. I want to use SSS, so I need 1 more side. Okay, well, the only remaining side is this one in the middle. And again, hopefully you've already figured out what that property is. If they're overlapping, TR is congruent to TR. Okay, TR is in this triangle, and it's also in this triangle. That's why I have to say it twice. We're talking about the same length in 2 triangles, and it's by the reflexive property. Hopefully you're seeing that one enough that it's starting to become second nature to see that. Hopefully that should be an easy one to see. If not, you really got to start looking for that. All right? We've now got 2 sides and then 1 in the middle that's marked the same. We've got 3 sides now. That means the triangles are congruent. And again, it's because of the whole thing that we're focusing on today, which is SSS. You have to actually say that at the end. We're going to be learning several other shortcuts other than SSS. We're going to be doing SAS, we're going to be doing AAS. Okay, there's going to be lots of other ones that we do. You have to specifically say which one you're using. Otherwise, you're not talking about the correct one. You're not being specific enough. Okay? And I believe, let's see. All right, so we do have an extra one. If you're feeling like you are solid on this, you got it, you know what you're doing, then you're okay. You can start working on the homework. If you need another example, this is another one that you can look at. It's got a lot more going on, okay? But it still has some good things that we can look at. Again, check our givens. It tells us WX is congruent to VZ. Well, that's already marked in the picture, so that's good. WY is congruent to VY. Okay, that's already marked in the picture. Good. YZ and YX are already marked, so that's great. Okay, so everything is marked. We're all good there. We're trying to prove that VWX, so this triangle right here, is congruent to WVZ. So we got some overlap here. So there's kind of a lot going on with this one. Okay, so I'm still looking for side. All right, well, I've got 1 side here and 1 side there, so that's given. So I got that done. All right, this part is where they overlap. So I can say WV is congruent to WV. Again, that's my reflexive property. So I've got 2 of the sides of the triangle done. Oops, can't spell reflexive. Reflexive property. Okay, the last one is kind of a funky one. It's this one on the bottom triangle, and it's this one on the top triangle. Okay? Well, it tells me that WY is congruent to VY, and it tells me YZ is congruent to YX. Okay, so that must mean the whole length is congruent to each other. Okay, so I can say that they are the same. Okay, and I can do that by saying addition of segments. Okay, so WZ is congruent. And running out of time, so that's why I'm not really going into detail, but you can check the notes if you need it.